Now we are going to see how to use algebra skill to find the exact values of limits of functions at various points. So for this purpose, we use sample examples to illustrate the method. So now we are going to start with a simple example of computing the limit as x approaches 2 of x squared minus 4 over x minus 2. So if you consider this problem, so the first thing we try to do is substituting in place of x2, but this is impossible because of division by 0, which is a bad, dangerous thing to do. So therefore, what we are going to try is that to transform the given function to an equivalent expression. So to do this, we use either factoring, simplification, all that stuff that we learned in school. So therefore, now we try to simplify this, and the whole idea is to get rid of, in some way, this expression, x minus 2. So therefore, one way to do is we can factor the top one as x minus 2 times x plus 2 over x minus 2, and which is equals to x plus 2, provided that these two cancellation is possible if x is different from 2. So what we are saying is that, so the expression this is the same as this one only for x different from 2. So since we are interested in the value of this as x approaches 2, therefore we can replace this object by x plus 2. So therefore, the limit as x approaches 2 of x squared minus 4 over x minus 2 is the same as the limit as x approaches 2 of x plus 2, which is equal to, by plugging in place of x2, we get 2 plus 2, 4. So this is the exact value of the limit of this function. Okay, now let us consider a second example. Let us consider, say, finding the limit as x approaches, say, 1 of x plus 3 minus 2 over x minus 1. So what is this value? So as you can see, again, plugging in x is equal to 1 will cause division by 0. So therefore, we should be able to simplify this in more simple form so that we can get rid of x minus 1 from the bottom. So therefore, we do that now. So therefore, square root of x plus 3 minus 2 over x minus 1 can be written as in a new form by using or by multiplying the top and the bottom by the same quantity, but as a result creating a new expression that's more simpler than this. So therefore, x plus 3 minus 2 over x minus 1. So we can multiply the top and the bottom by the, what we call it, the conjugate of the top expression, so which is the square root of x plus 3 plus 2 over the square root of x plus 3 plus 2. So this is 1, of course, but it will create a miracle, and it will create a more simplified version of the given expression. So therefore, simplifying this, we get, so if you multiply the top two expression, we get x plus 3 minus 4 over x minus 1 times the square root of x plus 3 plus 2, which gives you x minus 1 over x minus 1 times the square root of x plus 3 plus 2. So this will be, as a result, we get, therefore, the square root of x plus 3 minus 2 over x minus 1 equals, so we can cancel these two. So as a result, we get 1 over the square root of x plus 3 plus 2 for x different from 1. So these two objects are equal for x different from 1. Since we are interested as x approaches 1, not necessarily at 1, therefore as a limit, as x approaches 1 of x plus 3 minus 2 over x minus 1 will be the same as the limit as x approaches 1 of this expression, which will give you, if you replace x by 1, 1 over the square root of 4 plus 2, which is 1 over 4. So this is the exact value of the limit. So now, finally, let us consider another example to illustrate another techniques, again on the same theme. So let us evaluate the limit as x approaches 1 of, maybe better, 3 from the right, of x squared minus 5x plus 6 over x minus 3. So just bringing this absolute value expression, sometimes we'll be faced by this kind of expression. So the technique is similar. So if you plug in 3 at the bottom, you'll get 0. So therefore, we cannot replace x by 3. So one way to do is that to combine factoring and use the definition of absolute value to get rid of the absolute value sign from the bottom. So therefore, that is what we are going to do now. So x squared minus 5x plus 6 over x minus 3 is the same as, if you factor the top, it becomes x minus 3 times x minus 2 over x minus 3. So as it is, we cannot cancel the 2 because this is already within the absolute value sign. So, but remember the definition of absolute value. So the absolute value of x minus 3 is itself if x is greater than or equal to 3. Otherwise, it is the negative of x minus 3 if x is less than 3. So therefore, based on the given situation, since we are interested as x approaches 3 from the right, so we take the top branch. So therefore, this becomes x minus 3 times x minus 2 over x minus 3. So which will cancel. So as a result, we get x minus 2 for x greater than 3. So therefore, we conclude that from here, the limit as x approaches 3 from the right of the given question is the same as the limit as x approaches 3 from the right of x minus 2, which is 3 minus 2 is equal to 1. So therefore, you see, using elementary algebraic technique, we can find the exact value of the given expression. So, but this doesn't mean that always we can, things will be like that, but most of the time, like expression like this